consider the next problem on Coulomb's law. It reads point charges of +2 microcoulomb, +4 microcoulomb, -6 microcoulomb and +8 microcoulomb are placed at the corner A, B, C and D of a square ABCD of side 0.2 meters. Calculate the resultant force on the charge at D. To solve this, let us first consider the square of ABCD and we'll first place the charges as given. A charge of +2 microcoulomb is placed at corner A. So let me take QA is equal to 2 10 to the power of -6 +4 microcoulomb placed at corner B, which should be 4 10 to the power of -6, and -6 which is placed at C, so should be 6 10 to the power of -6 coulomb, which is a negative charge, plus 8 microcoulomb which is placed at corner D, 8 10 to the power of -6. Now as it is a square, by symmetry it is known the distance from all the 4 points, that is from A to B, from B to C, from C to D and from D to A should be the same, which we will consider it as R, and it is equal to 0.2 meters. So with this given data, the first thing that I have to find is what is the force on the charge at D due to the charge at A. We know what are the values of charges at D as well as charges at A, as well as the distance is also known. So to find out, we will take Coulomb's law, where Coulomb's law is given as force between or force on D due to A is equal to 1 upon 4 pi epsilon naught QA into QD upon square of the distance between A and D. So I should get this as 9 10 to the power of 9 into 2 10 to the power of -6 into 8 10 to the power of -6 divided by the square of the distance, which has to be 0.2 the whole square. On simplifying this, I should now get an value which is 144 10 to the power of 9 into 10 to the power of -12 divided by 0.04, which gives me an answer which is equal to 3600 10 to the power of -3 Newton, or you can even write it as 3.6 Newton. And remember, this force is from A to D, or you can say it is the force which is acting on D due to A. Hence, this force should be along DA, or sorry, I should call it as force along AD, and we representing it as force DA. Next, now we'll find out what should be the force on D due to the charge at B. For that, I will have to consider that expression which is given as 1 upon 4 pi epsilon naught charge at B into charge at D upon the square of the distance between B and D, which has to be a diagonal. So to find out RBD, you can now make use of Pythagoras theorem, where Pythagoras theorem gives you square of hypotenuse should be equal to the square of the base plus square of the altitude, or you can even consider it as height. So I get RBD squared, which is the hypotenuse, should be equal to distance between AD, square of that value, and the height, which is AB, and square of that value again, which gives you RBD squared is equal to R squared plus R squared, which is 2R squared. So RBD squared should be equal to √2 into R, where the diagonal value is √2 into R value, which is 0.2. So I get this value as √2 into 0.2 meters. So to find out this force on D due to B, force on D due to B is equal to 1 upon 4 pi epsilon naught QB into QD upon RBD squared, where this gives me an expression which is 9 10 to the power of 9 into 4 10 to the power of -6 into 8 10 to the power of -6 divided by root 2 into 0.2 the whole square should give you 288 10 to the power of 9 into 10 to the power of minus 2 divided by 2 into 0.04, or you can even write it as 0.08, which on simplifying should give you an answer which is equal to 3600 10 to the power of minus 3 Newton, or when you even write it as 3.6 Newton. Now remember, this force is from B to D, or you can say we have calculated the force on D due to B, hence this force should be along DB, or should be along BD. So force DB is along the line BD. So now once we have calculated these forces, I have to now find out what is the force on D due to C. So the force on D due to C can be given as FDC, which is equal to 1 upon 4 pi epsilon naught charge at point C into charge at point D upon RAD the whole square. So FDC is equal to 9 10 to the power of 9 into 6 10 to the power of 9 into 8 10 to the power of 9. I think there should be a correction over here. I should have charge at C as 6 microcoulomb. So this should be 6 10 to the power of minus 6 and 8 10 to the power of minus 6. I hope all of you please check these corrections. It is given as 10 to the power of 9 upon square of the distance, which is 0.2 the whole square. Simplify this, you will get 432, and your powers should be into 10 to the power of 9 10 to the power of minus 12. I think this correction has been rectified over here, so all of you please make a note of it. Into this previous section where you'll had 10 to the power of 9 and 10 to the power of 9 has been changed as 10 to the power of minus 12, divided by 0.04. So you should get a value which is FDC is equal to 10,800 10 to the power of minus 3. On simplifying, you get an answer of 10.8 Newton. Now we find out this was the force on D due to C. So this force FDC should be along D to C because it is from a negative and positive charge. So this is along DC. So we have got all the forces which were